So this is the test review for Chapter 3, Sections 1 and 2. Looking at problem number 1, when you choose the correct description. So what we've learned on the descriptions is if they're parallel, it'll be inconsistent. If they are exactly the same equation, then it'll be consistent and dependent. If they intersect at only one point, then it will be consistent and independent. And for it to be inconsistent and dependent is impossible. So when we look at the two equations, we set them up into slope-intercept form. The first one would become negative y, negative 3x plus 5, and then divide by negative 1 would be positive y, positive 3x minus 5. The second equation would become, we write it as 2y equals 6x minus 5. Then divide everything by 2, and y would be 3x minus 5 over 2, or 2.5. So since we notice that both of them have slopes of 3, and their y-intercepts are different, then they're going to be parallel. They're not exactly the same line, but they're going to be parallel. So C would be our correct answer. Number 2, we're asked to solve this system of equations using substitution. So we want to take one of the two equations and isolate one of the variables. So this equation, the second equation, would be the easiest one to isolate x, because all I have to do is add 4y to both sides, and I get x equals negative 21 plus 4y, or 4y minus 21, either way. So I take that and I go back to the first equation, and instead of x, I'm going to put negative 21 plus 4y plus 2y equals 7. So now I only have the variable y. I'll distribute and get negative 63 plus 12y plus 2y equals 7. I'm going to add 63 to both sides. And I'm going to combine my like terms there, and I get 14y equal to 70. Divide by 14, and y would be 5. So with a value of 5, then I can take that and plug that into this equation where I isolated x. X would be negative 21 plus 4 times 5, which would be negative 21 plus 20, which is negative 1. So you could write it like this, or you could write it as negative 1, 5, as long as x is your first value. On number 3, we want to use elimination. So we either want the x's to drop out or the y's to drop out. But in order for that to happen, then they have to have the same coefficients, but opposite signs. Since we already have opposite signs here on the y values, then it would be easiest just to multiply the top equation by 2 and form 4x plus 2y equals 4. I won't change the second equation. Leave it as 3x minus 2y equals negative 11. And now when I add the two equations together, I get 7x, those cancel, equals negative 7. So that means x would be negative 1. So I take that and substitute it back into one of my two equations. I'm going to go with the top one. So 2 times negative 1 plus y equals 2. So negative 2 plus y is equal to 2. Add 2 to both sides. Y would be 4. So then the answer would be negative 1, 4. Number 4, in order to use substitution, since 2, I can't multiply something by 2 and get at least integer-wise, and get 3. I can't multiply 3 by anything to get 5, so I may have to adjust both equations. Since I already have opposite signs there, then I'm going to try to get the y's to drop out. So if I can get them to become a negative 15 and a positive 15, just multiplying that means all I'll have to do is multiply the top equation by 3 and the bottom equation by 5, and that'll become 9x minus 15y equals 42. And then the second equation becomes 10x plus 15y equals 15. And so now when I add the two equations together, the y's will drop out. I'll get 19x equal to 57, and because the y's dropped out, so x, I divide by 19, x would be 3. So I take that, substitute it back into one of my two equations. I'll use the second one this time, no reason, just a preference. Substituted x back in, or 3 back in for x, becomes 6 plus 3y equals 3. Subtract 6 from both sides. 3y is negative 3, which means y would be negative 1. So my solution here would be 3, negative 1. For number 5, I'm asked to solve this system of equations by graphing. So I need to translate both of these into slope-intercept form. The first one won't be too difficult. All I need to do is subtract 3x from both sides, and y would be equal to negative 3x minus 4. The second one, however, is going to take me a couple steps. I'm going to subtract x from both sides. Negative 2y would be equal to negative x minus 6. Then I'm going to need to divide everything by negative 2. Y will be a positive 1/2 x plus 3. So I'll take both of those equations and go over to the graph. Okay, so y equals negative 3x minus 4. Has a minus 4 as its y-intercept, and it has a negative 3 slope, so I'm going to go up 3 and over 1 this way. I'm going to go up 3 from there, over 1, up 3 from there, over 1. So that'll be a negative 3x minus 4. The line passes through those. Looks like this. Then I have a 1/2 x plus 3, positive 3, it's a y-intercept, and it has a 1/2 slope, so up 1 over 2, up 1 over 2, that same pattern, I think that's going to be my point of intersection. So the line that goes through those points looks like this. That is my point of intersection. According to that is negative 2, 2. Number 6, I need to use these three inequalities and find the corners of the triangular feasible region that those border. So we have three inequalities. I call it A, B, and C. And so we need to find the intersection between all of those, all combinations. So if we treat them like equations, we have the equation x equals negative 2. We have x plus y equals 7, and y equals 2x plus 1. Then the corners of that, again, would be there's A, there's B, there's C. So between B and C, what's going to be the point of intersection? Well, I can probably put that in the calculator. Subtract x from both sides so I can get it into y equals form. Y would be negative x plus 7, and y would be still 2x plus 1. So if I put both of those into y equals in my calculator, I can find the point of intersection. Put them into y equals, and then second trace, do the intersection, and I get intersection point at 2, 5. Now, what about A and B, and A and C? Because I really can't put that into y equals because there is no letter y. So what I can do, though, is put negative 2 in for x. So y would be minus negative 2 plus 7, which would be positive 2 plus 7, or 9. So the intersection point between A and B would be the point negative 2, 9. Then I do the same thing with A and C. Put negative 2 in for x. So at y would be negative 3. So we have the point negative 2, negative 3 as the point of intersection between C and A. Now, just to prove that this looks like what it's supposed to, I'm going to draw a rough graph. And the line x equals negative 2 looks like this. And we want an inequality, which means we're going to shade x greater than negative 2. So that means we would be shading this way. In green, I'm going to do negative x plus 7. Here's 7. And so negative x plus 7 would look like this. And so we're going to shade below on that one. So it would be down here. And then 2x plus 1. Here's plus 1. It's going to be a 2 slope. So it's going to do something like this. And then shading above that would be, make this triangle right here the area where they all overlap. You don't have to do all this, I'm just proving to you. So we have the point 2, 5, which is about right there. We have the point negative 2, 9, which is about right there. And we have the point negative 2, negative 3, which is about right there. Looking at number 7, again, we're trying to classify these as consistent independent, consistent dependent, inconsistent, or inconsistent and dependent. So we remember parallel means going to be inconsistent. If they're the exact same line, it's consistent and dependent. If they intersect at one point, it's consistent and independent. Inconsistent dependent is not possible. So which one is this? Well, we need to get both of these set up into slope-intercept form. So the first one, so in slope-intercept form, the first one is negative 2x minus 3, and the second one is 2x minus 8. So their slopes are not the same. So they are going to intersect at one point. So it's going to be A, consistent and independent. Part 2, when writing the lines in slope-intercept form, you get negative 3x plus 3 and 1/2 x minus 2. And again, since the slopes are not the same, different slopes, then it's going to intersect at only one point. So again, it's going to be A, consistent and independent. Number 8 is asking us to go in the opposite direction. They're giving us the graph, they're giving us the point of intersection. They want to know what are the equations of the two lines. So all you have to do is write the equations of these two lines. Okay. So line number 1, line number 2, let's see, number 1 would be y equals, it has a 2y intercept, and it is a 1 slope, up 1 over 1, so we can call it 1x, or just x, plus 2. The other one has a 0 as its y-intercept, and its slope is up 3 over 1. So it's just going to be a 3x plus 0, or just 3x. 9 is the same way, except we have inequalities. So let's deal with, call this one the first one, solid line, which is the equation as a line. It would be y equals negative x, because that's a negative 1 slope, plus 1. And it's going to be a solid line shading below, so it's going to be a less than or equal to. Number 2 is going to be a horizontal line, so that means it's going to be y equals, with no slope, or 0 as its slope, and it hits at negative 1, so we're just talking about y equals negative 1. But it's a dotted line, it's going to be shading above that, so I think I have this one wrong. This is supposed to be y less than or equal to, because we're shading below. This is going to be shaded above with a dotted line, so I believe that's what we're looking at as the two equations. Number 10, we're looking at the coordinates of the vertices for this feasible region. Well, y greater than or equal to 0, x greater than or equal to 0, that is the x-axis. This is the y-axis. Okay, so we're talking about everything in quadrant 1 below, since it's a less than or equal to, below negative 2x plus 4. So if you put these two are going to intersect, the x-axis and y-axis intersect at the point 0, 0. So that's one corner. And then if you put 0 in for y, subtract 4 from both sides, divide by negative 2. So you get 2 is your x value, so the other point would be 2, 0. When I put 0 in for y, and then when I put 0 in for x, y would be negative 2 times 0 plus 4, 0 plus 4 plus 4. So 0, 4. Those would be the corners of that feasible region. Number 11, y equals negative 3x plus 5 and y equals 3x minus 7 has how many solutions? Well, if we look at the slopes, this one has a negative 3 slope. This one has a 3 slope. So the only possibilities are that it has one solution, it has 0 solutions, or it has infinite solutions. And it would only have infinite solutions if these were the exact same equations, and they're not. It would have 0 solutions if they had the same slope. And we don't. This is a negative 3, this is a positive 3. So it has to have one solution. If they don't have the same slopes, then they're going to intersect at one point. One solution. Number 12, if the first equation of the system is multiplied by 3, what number would you multiply the second equation by to eliminate the x variable by adding? So if we take and multiply this top equation by 3, okay, that would become 12x minus 9y equals 18. So if we need the x's to cancel out, this is going to have to become a negative 12. That means we're going to need to multiply this through by negative 2 to become negative 12x minus 2y equals negative 20. Then when we add them together, the x's will drop out. So what number would you multiply the second equation by? Negative 2. And same sort of problem for number 13. If the first equation is multiplied by 2, what number would you multiply the second equation by to eliminate the y variable? We need the y variables to eliminate this time. So if we multiply it by 2, we get 8x minus 6y equals 12. So if we want the y's to cancel, then this is going to need to become a positive 6y. Well, then I'll multiply by 6. That would become a 36x plus 6y, just like I planned, equals 60. So when I add them together, I get a 0y. So your answer was you multiply by 6.